Welcome you all to the one more session of digital electronics. In this session we are going to see the circuit diagram for generation of gray from binary. Means the circuit which converts binary to gray and gray to binary. Actually we are having two types of or two method of generating our gray code. Like gray code can be generated using two techniques. The first technique is called as mirror technique. So using mirror technique we can able to generate the gray code. The second one is gray code generation using logic diagram or using logic diagram itself, or logic expression. Logic diagram I will write it. So these are the two techniques which are available for generating a gray code. Now for example, like let's get into it and see how I can generate a gray code from binary to gray. This is my gray code, this is my binary code. Binary code, you know generally that it is 8421 code. Yeah? Now let's see how this can be done using these two techniques. I am taking my mirror technique first. So if I am taking mirror technique, on the left hand side I am going to represent my binaries first. So binary means 8421 code, right? 8421 code. I am representing all 8421 code for my all the numbers. Let's see. For 0 it is represented as 0 0 0 0. 1 is represented as 0 0 0 1. 2 as 0 0 1 0. 3 as 0 0 1 1. 4 0 1 0 0. 5 as 0 1 0 1. 6 as 0 1 1 0. 7 0 1 1 1. 8 1 0 0. 9 1 0 0 1. 10 as 1 0 1 0. 11 as 1 0 1 1. 12 as 1 1 0 0. 13 as 1 1 0 1. 14 as 1 1 1 0. And 15, the last one, as 1 1 1 1. You know all these numbers. Now I will write my gray equivalent for this 8421 code. How it is, just see here. I am just representing with a lines so that it will be easy while writing the numbers. I am using mirror technique. Let's differentiate with a different color so that it will be easy for you to identify also. I have taken different number. Now I am representing my numbers in gray code using a mirror technique. The first technique that I am talking about is mirror technique. There are basically two elements in my gray code, that is 0 and 1. Either it is binary or gray. The basic elements of machine language or the processor understandable languages, the basic element is either 0 or 1. So I am taking basic element, that is 0 and 1 as my two basic elements. Either it can be a 0 value or it can be a 1 value. So I am taking a 0 and 1 and I am placing a mirror here. Mirror 1 I am placing here. I am placing a mirror 1. Now after placing mirror 1, how does this 0 and 1 look like? It looks like 1 and 0. Done? Now after placing the mirror image, before mirror place two zeros on the top of the mirror and two ones on the bottom of my mirror. Next again place a mirror. My mirror 2. Now when I am placed in my mirror 2, the image will look like 0 1 1 0. So 0 1 1 0. Next this will look as 1 1 0 0. What I told you, when you return the image values oppositely in the downward, then place zeros before the mirror and ones after the mirror. Now again mark one more mirror here, mirror 3. When you have written a mirror here, again my values will look at 0, 1, 1, 0, 0, 1, 1, 0. So 0, 1, 1, 0. Next again 0, 1, 1, 0 is my value. Next 0, 0, 1, 1. 0, 0, 1, 1. Next 1, 1, 0, 0. 1, 1, 0, 0. Next, this will be 4 ones and 4 zeros. So 4 ones, 4 zeros. Now I have completed my writing the mirror image of my numbers on the top of the mirror. Then after that I need to place zeros before the mirror. So I am placing 8 zeros before the mirror and 8 ones after the mirror. So this is how I have generated using a mirror concept for binary to gray conversion. Now after this, we'll get on to the logic diagram concept. Let's see how the logic diagram will work for me in generating a gray code. Now we'll write two values. For example, for 15 I am having 1000 as gray value. Let's write that value. Binary. For 15 I got 1000. So let's write with a pen my binary values and gray values. Binary as 4 ones, I got 1000. Now again one more value will take randomly. For 3 the value is 0010. For 3 the value is 0010. 0010 as my value. Now you got, I have taken two sample values like this. Like for 15 value it is 1000. For 3 value it is 0010. Let's see how the conversion goes. We'll see both the things, either from binary to gray as well as gray to binary also. Using a concept of logics, like or logic gates, how we are going to design these logic gates and how we are. Now let's see the conversion from binary to gray. I am taking just for 4-bit only. You can do it for either 2-bit or 3-bit or 4-bit, 5-bit, 6-bit. For n bits you can do you can follow the same concept. Now for binary to gray, for 4-bit I am taking. Now I am considering these 4 bits in binary as B3, B2, B1, B0, and 4 bits in gray as G3, G2, G1 and G0. Now the conversion. B from binary to gray. I am taking for binary to gray, B3 I am directly taking as G3. B3 I am taking directly as G3. Next, B2. I am going to perform exclusive OR operation between B3 and B2. So that I am going to generate a G2. Next, this B2 and B1. Again, an exclusive OR operation going to give me a G1. Next, B1 in exclusive with B0 will give me an operation of G0. So this is the logic circuit, or this is the diagram which is going to tell me the conversion from binary to gray. Let's verify whether I am getting these values on my circuit or not. Okay, I am taking a separate color to differentiate it. Now I am considering 1 1 1 1. I need to get 1000. Now you know exclusive OR gate operation. When differential inputs are applied, then only my gate is going to produce a high output. When same inputs are applied, a low output is going to get generated. Now you see 1 directly given as 1 as output. Now 1 and 1, same inputs are coming for exclusive, so my output is going to be 0. Next, 1 and 1, same inputs, output is 0. 1 and 1 same inputs, my output is going to be 0. So my value is 1 0 0 0. So I got my 1 0 0 0 value. Next, similarly, we'll check for 0 0 0 1 1 0 0 1 1. Take 0 directly, the straight line. Next, 0 and 0 exclusive OR operation is going to give me 0 only. Why? Because same inputs are there. Next, 0 and 1 differential inputs. Then my output is going to be 1. Next, 1 and 1 same inputs. My output is going to be 0. So my value for 3 will be 0 0 1 0. So 0 0 1 0 with what I got here. So this is how you convert binary to gray. Let's check again for gray to binary. Let's see how the gray to binary works for us. Now I'm writing the conversion for gray to binary. Means I'm doing a reverse operation. I'm doing from gray to binary thing here. Now this will be, I'm going to take G3 directly to B3. Next, G2. For G2, what I am going to do? I am going to perform exclusive OR operation between these two things, so that I am going to get B2. Next, G2, I am not going to take G2 here like this. We'll remove this line. And I am going to take this output line as input for my next gate and G1 as my input, and draw an exclusive OR gate which is going to give me B1. Next, similarly, this output I am going to take, and this I am going to give it as G0, perform exclusive OR operation which is going to give me B0. Let's verify whether this is giving me actual binary or not. Let's consider input values as required by our thing. I need to consider gray here, so I am considering 1 0 0. First value I am considering 1 0 0. How much I need to get? I need to get 15. That is all ones. So I am bringing 1 directly. Next, 1 and 0, two differential values. Exclusive OR is going to get able to generate one value here. It is going to generate 1. Next, this one is going to get a travel here. What happens? 1 and 0 differential values, output is 1. Next, again this 1 is going to get a travel here. 1 and 0 is going to give me 1. So I got all 4 ones, the required thing I got. Next, similar, I am going to consider this 0 0 1 0. That is 0 0 1 0 as my input values. What I need to get? I need to get 0 0 1 1. So I am bringing this 0 directly. Next, 0 and 0 means the same input bits are there. The output is going to be 0 here. Next, 0 and 1 differential inputs, my output is going to be 1. 1 and 0 differential inputs, my output is going to be 1. So 0 0 1 is my value. So I got my 0 0 1 1. So this is how you are going to use this exclusive OR gate arrangement in converting binary to gray or gray to binary. And the first technique was mirror technique. So this is what in this session we have seen how to generate the gray using mirror technique and using exclusive OR operation. Thank you one and all.